Hey everybody, Dave Lindberg, DB Enterprises here in Hong Kong, providing you an update on Zumi Systems and their new HP85 measurement tool. It's a complete headphone and earphone measurement tool. It integrates an ARM core embedded computer, an 8-channel simultaneously analog front end, measurement mics, couplers, an output headphone amplifier, and digital interfacing. And it's all done in a compact and portable package that's agnostic. It doesn't need a computer with it. It's a standalone, custom, purpose-built system. It's suitable for measurement and quality control purposes in both development and production environments. So whether you're benchmarking against a competitor or using it on inline testing in production, these systems are suitable for both of those applications. It can also provide measurements for ANC characterizations for both feed-forward and feedback ANC topologies. So what are the features on this system? It features a Bluetooth module that acts as an AD2P source and high-pass filter audio gateway for Bluetooth devices. It has two 3.5 stereo audio jacks, which could be used for headphones and also for external speakers. The HP85 is powered by a 5 volts USB socket. We make that so it's easy to ship around without batteries embedded. But if you wanted to have a lithium-ion battery or similar inside the device so you can take it completely portable and recharge it, we can do that customization totally for you. So the HP85 executes sequence-based measurements and calculation processes that enable complex analysis tasks. Now finally, everything is data logged. There's no point in doing all this measurement if you can't know, like, this serial number product, what was the measurement results. So everything can be data logged via SD card, and even nowadays they have SD cards that have Wi-Fi capability. So if you have 5 or 10 of these systems in a production line environment, everything can be sent back to a central server, so everything's logged and there's no mix-ups on the data. So finally, interfacing to this system is done via either I2C, Bluetooth SSP, or general purpose input-output pins. So right now, since we're all in quarantine, we're going to send it over remotely to Simon in Japan, and Simon's going to give you a rundown and demonstration on how the HP85 works.
The HPA85 is a complete integrated test and measurement tool for headphones and earphones. It's designed for over-the-air or on-the-air headphones, like so, or for insert earbuds, like so. The unit is powered from a USB 5-volt supply, either by a wall charger or power bank or a PC. If it's connected to a PC, this is also a USB serial link, so we can get our data and so on through that link, or configure the device, etc. It also supports a lithium-ion battery. We have one installed in this unit, so we'll just run on battery. The power consumption is around 250 to 300 milliamps, depending on the amount of power you're outputting. So yeah, you'll get a couple of hours, so 2 or 3 hours out of a typical smallish, 1000 milliamp hour battery. Let's take a look at a test. This is a default test profile for quality control of headphones, quality control or assessment of headphones. So we plug it into, we're using a cabled headphone, plug it into the front socket, put the headphone on the tester, and away we go. And in fact we failed because I think I've got the left and rights around the wrong way. So this test will also detect channel assignment. And there we go, excellent. We get a frequency response for the left and right channels. We take a channel balance and then THD at a number of frequency points across the spectrum. So the THD in this case is sort of comfortably under 1%. That's very good. The classic use for a frequency response is to assign, or for a frequency response quality control is to put limit curves or bounds around that. And we can do that by using this measured data. Assume that this is a reference sample. We'll set bounds based on this reference sample, and from there on we can test however many products against this bound mask. If, for example, we had one unit was leaking on one side, we'd find that the bass was rolled off and went outside the allowable limits, and therefore the unit fails. Another interesting use case is when we just want to quickly look at a frequency response without going through a long test procedure, and for that we can just take a quick frequency response. There's a name, quick FR, press and hold, and that will set the device into a continuous looping test mode. So the benefit is it will just run endlessly until we press stop, and we can get a frequency response and let's say play around. We might be doing tuning or comparing a few different products. If we wanted to compare some products, we can just grab a hold curve on that one and compare to something else. We can also output to Bluetooth, have a Bluetooth transmitter built in, A2DP and HFP protocols for audio. So let's go and choose the output channel, set the output channel to Bluetooth. When we do that, the device will start searching for a headset to pair with, and so we need to put our device into pairing mode. We'll do that. It's found the device, it's calling it. And in fact, what I'll do is I'll put it into a continuous running mode rather than just one sweep. There we go, it found the device, establishing the connection, and away we go. So these are actually Apple AirPods, which we can take a look at. They have an interesting characteristic, that is they self-adjust. So if we watch that frequency response, in fact we'll store that curve and we'll see what happens as it changes over time. So it has some ability to self-measure and adjust its own frequency response. There we go, and it's reducing that low frequency. If we intentionally create a leakage on one side, we'll watch it boost its level up to try and compensate. Let's see what happened then. I'll seal it again. And there it goes. It'll have to adjust back down. I'll zoom in so we can see that. Interesting characteristic. I don't know the logic behind that. So there's a quick look at a couple of simple use cases. On the back panel we have SD card socket. If we have an SD card installed, we'll log all of the measured data, frequency and magnitude phase points, as well as a summary of each test, so we can do some post-analysis or whatever's required there. We have an additional output that be used for external speakers or some other output. Then 2 pin headers. These pin headers have communications for I2C, SPI, UART, as well as just digital pins it can be used, for example, for a foot switch to start and stop a test, or to indicate pass-fail results, or if the test is in progress, etc. We also have 4 additional inputs for microphones. Those are used quite often for ANC related measurements, where we want to also take data from the ANC microphones. So 4 additional inputs there. A total of 8 channels, and 2 are always sensing the output voltage, and then we have our measurement microphones in the ears, and then 4 more channels available for other applications. So that's a quick look at the device.
Alright, Simon, thanks for that detailed demonstration and explanation. Finally, people just want to review the applications where you can consider to use the HP85 with your company. So engineering, development, tuning, and analysis is a key area where this system is fantastic. Mass production quality control, and also ANC production trimming, and it's extremely fast. So this system is capable to tune your ANC headphones very quickly. Also for outgoing quality control inspection, making sure every product leaving the line is acceptable, and also for the marketing or product development guys, benchmarking or assessing the competition. You can use this system. It's a small portable thing. You don't need to go and ask the test engineer to do a test for you. You can do it yourself in a marketing or product development office. So if anybody wants to know more about the HPA85, please contact me, Dave Lindberg, at DB here in Hong Kong, and we'd be happy to field your questions or possibly set up a call to discuss more with your company. All right, thanks and have a great day. Bye-bye.